I'm Anil Kumar. Welcome to my series on rational expressions. In this video, we will learn how to add and subtract rational expressions. So I have an example for you, and we'll try to understand the concept by solving this example. So it is 2 over 5 mn minus 3n plus m squared divided by 2m cubed plus 2. Now here we need to add 3 and take away all this from 2 over 5mn. Now before we begin to solve this particular question, let us get reminded of what we did for fractions, since this is a very important question to be answered and understood, right? So we'll get back to rational expressions once we review what we did with fractions, right? So let me take an example here. Let us say we want to add 1 over 45 with 1 over 30. Right? How do we do that? Well, step number 1 for us is to find factors of 45 and 30, right? So what are the factors of 45 and what are the factors of 30? To get the factors of 45, we at times will do prime factorization, especially when there are big numbers, right? So we say this is 5 times 9, and 9 could be factored as 3 times 3, right? So once we do that, we know 45 could be written as 3 times 3 times 5. Similar operation we'll do for 30 also. We say 30 is 3 times 10, and 10 could be written as 2 times 5. And therefore, I could also write 30 as 2 times 3 times 5. Next operation is to find the lowest common denominator, right? So the lowest common denominator is seen from these factors. As far as 3's are concerned, we have 2 3's in 45. So we use 3 square, or you can write 3 times 3. And 5, both have 1 5. We take a 5. 2 is there in 30 but not in 45. So we'll take a 2 also. So 5 times 2 is 10 and this is 9. That gives us lowest common denominator of 90. Correct? Now once we get 90, we know exactly that we should be writing 1 over 45 with denominator of 90 and also 1 over 30 with denominator of 90. We could do that by multiplying 45 by 2. I have to multiply numerator also by 2, right, to make it the same thing. Multiplying, dividing by the same number is as good as multiplying by 1. And in this case, I have to multiply and divide by 3. So once I do that, I get common denominator of 90. In the numerator for 45, I get 2. And for 30 in the numerator, I get 3. When we add them, we get 5 over 90, right? So we have actually added them. Next step is to simplify. I could divide both by 5 and could write this as 5 over. When I do 5 times 1, I get 5. 40 is 8. So 1 over 18. So I get my result here as 1 over 18. Does make sense to you? So exactly these steps will be done whenever we add or subtract rational expressions. We need to find common denominator. Correct? So let's decide what is the common denominator for all these terms. So that is our first step. So lowest common denominator is, we have 5 here, we have 2 here. As far as numbers are concerned, we need to take 10, right? So we'll take 10, 5 times 2, just as we multiplied this 2 with all of them. You get the idea, right? So 10, we took 5 from here and 2 from there, we just wrote 10. As far as m is concerned, we have a bigger m here, m cube, so we'll take m cube, right? So this is already included. Once I take m cube, n is not there, so we'll take n also. So that becomes our lowest common denominator. Now that really means that I have to write all the 3 terms with the denominator of 10m cube n. We are given 2 over 5mn. To make it 10, what will I do? Well, we have to multiply denominator by 2, right? So we're talking about denominator first. We have to multiply this by 2, we get it 10, m by m square. So these are the two terms which we consider. So we have to multiply by the same thing also, right? Does it make sense to you? So that is how we change the first term, ensuring that we have a denominator of 10m cube n. Perfect? Next term here, negative, we write down the term which is 3n plus m square divided by 2m cube. Now here we want to get 10, so I have to multiply by 5. Well, I wrote 10, I could have written 5 times 2, it becomes easier to work, right? So better could have been writing this as 5 times 2 times m cube n, right? So we know we have a 2, but we do not have a 5, so we write 5, okay? M we already have, n we don't have, so we'll put this. So we'll multiply and divide by 5n, right? Then next term is 3, which has a denominator of 1, so we don't even have to think, we have to get all these terms in place, right? So we'll multiply with 10 m cube and n, and we'll also divide by 10 m cube and n. Correct? So still our rational expression is exactly same as it was, because in each expression we only multiplied by 1. Perfect? So this is a very important step. Now, since we have a common denominator, which we could write like this. This is the common denominator, right? Everything, this 10 m cube n becomes the common denominator for all the three terms. And in the numerator, we have to multiply individually, right? Just as we did here, 2 times 1 and 3 times 1. So we'll do the same thing. We get 4m square from the first term. Now in this particular thing, it's like very important to understand that 5n actually multiplies to both of them. We have to apply distributive property, right? Otherwise you'll do a mistake, right? So we have to multiply it with both to get our answer, correct? So we get 5 times 3, and also the sign negative. So, or you just put negative here and put a bracket. That'll be safe for now. Then in the next step, you can open the bracket. So 5 times n times 3n will become 15n squared. When you multiply this, it becomes 5. I'm sorry, let me write plus first. It becomes 5. We write numbers first, right? We can write m square n. So that is what it will be. And close the bracket. Now the next term for us is 3 times all this. So it becomes 30 m cube n. Perfect. At this stage, we have to look for common terms if we have any to combine. Now, if you see this, literally, there are no common terms, right? So there are no common terms in this. So we'll just open the bracket and rewrite. At times, you will have common terms, okay? So this is just an example to illustrate the process. Okay, so when we open this bracket, signs will change. We'll have minus 15 n square, and this is also minus 5 m square n, and that is plus 30 m cube n, and the denominator is 10 m cube n. Is that clear? So that is the first part, and that is we have added and subtracted our rational expressions. The second part here is to write restrictions, right? So don't forget that. It is not specified, but you need to state restrictions. I'll say state them always. Right? So in rational expressions, remember, by definition, we are dividing two polynomials and the denominator cannot be 0. So whether it is included or not, you have to state restrictions, okay? Now here, the denominator has got two variables, so m cannot be equal to 0 and n also cannot be equal to 0. Perfect. So that completes our work. As you can very clearly see, when we talk about rational expressions, we have these variables. In fractions, no variables. That is arithmetic part, correct? So now when we move into algebra, we work with variables and the term rational expressions, correct? So I hope that is absolutely clear. Now here is question number 4, which is for you to do. Simplify and state restrictions. So we have a subtraction example here and a addition. I'd like you to copy these questions, answer them, and then write them as comments. If there is any difficulty, you can always send me an email. Thanks for watching, and I hope that helps. Feel free to share my videos, and if you like and subscribe to them, that will be great. Thanks a lot and all the best.